we would like to find each of the following. We have here 3 times a vector in R3 minus 4 times another vector in R3. So this is going to give us some vector in R3. This is a linear combination of the two vectors shown here. We would also like to find the magnitude of a vector in R3. That's the vector 3i plus 4j minus 5k. And then we would also finally like to find a unit vector in the same direction as a given vector in R3. So the computations for vectors in R3 are analogous to those in R2. We just have an extra component, and we'll see what difference that makes. So here we're going to first distribute the scalar multiple across each component of the vector. So 3 times a vector in R3 is going to give us a vector in R3 with 3 times each of the components. So 6, 12, negative 3. And then minus, and we're going to do the same thing here, distribute the 4. So 20, negative 12, 8. And now subtracting vectors in R3 is just like subtracting vectors in R2. We will subtract the corresponding components. So we will get a vector in R3. The first component will be the difference of these first components. 6 minus 20, I'll write it for emphasis. 12 minus negative 12. And negative 3 minus 8. So this is the nature of the computation. And 6 minus 20 is negative 14. 12 minus a negative 12 is 24. And negative 3 minus 8 is negative 11. So this linear combination of two vectors in R3 gives us this vector in R3. Now we need the magnitude of a vector in R3. The vector I in R3 is the vector 1, 0, 0. The vector j is the vector 0, 1, 0. And the vector k is the vector 0, 0, 1. These are called the standard basis vectors in R3 because any vector in R3 can be written in terms of I, j, and k. For example, this one is negative 14i plus 24j minus 11k. Okay, so the next thing is, what do we do to find the magnitude of a vector in R3? So if you have a vector in R2, the magnitude is the square root of the sum of the squares of the components. And if you have a vector in R3, the magnitude is the square root of the sum of the squares of the components. It's the exact same sentence, but we just have an extra component to square and add to our sum. Okay, so let's get to the business of finding the magnitude of the vector in the problem. The vector is 3i plus 4j minus 5k. And first we'll write that vector in the form xyz. It's 3, 4, negative 5. And now the magnitude of that is the square root of the sum of the squares of the components. And that's square root of 9 plus 16 plus 25. That makes the square root of 50. 50 is 25 times 2. Square root of 25 is 5 times the square root of 2. Okay, finally, we'd like to find a unit vector in the same direction as a given vector. So we'll find the magnitude of this vector first. The magnitude of the vector 1, negative 2, 2 is the square root of the sum of the squares of its components, 1 squared plus negative 2 squared plus 2 squared. and that's 1 plus 4 plus 4 is 9. And so this vector has a magnitude of exactly 3. So to find a unit vector in the same direction, we will simply rescale this vector by 1/3. We'll take the reciprocal, and that is 1/3. So our unit vector is going to be 1/3 times the original vector. This will now have a magnitude of 1. And since this constant is positive, it will point in the same direction as the original vector. If we made this a negative 1/3, it would point in the opposite direction. And it would still be a unit vector. And so this is the vector distributing 1/3, negative 2/3, 2/3. This is a unit vector in the same direction as 1, negative 2, 2.